Hi, I'm Tom Marks. Welcome to another PlayStation 2 programming live stream. Today, November 5th, we're back doing more work on asset loading. Last time, we jigged things around a little so that we could load assets from a big blob file that I called a WAD. Kind of like in Doom, but different to Doom. WAD is just a very descriptive name, and so we got WADs working, right? We can pack a bunch of files together into one file, we can extract individual files from that. And I started doing this work on loading levels from a file, and to do that, I had to design a file format for storing levels. Let me make sure I have a different tool so I don't draw like that. Cool. So we designed a file format, and then we started writing some C code to parse it. Today we're going to jump back in where we left off, and we're going to try and get this part of the flow working, where we have a level, and we get it working on an actual console. And when I'm ready to test it, I have an actual PlayStation 2 hooked up to a capture card, and we can run it from there. So that's going to be a lot of fun. We're going to do cool things today. Anyone coming in, please say hello. Anyone who's following along the YouTube comments, I love hearing from you, and I love hearing what you're getting from this series. Lots of awesome people leaving lots of awesome comments, and so thank you all so much, and it's a really good journey. So let's get started with some code. I'm just going to resize my webcam just a little bit. I'm just gonna take a little bit less of a bite out of my window. Bobbius in chat, welcome. Good morning. Always my first chatter, 100% of the time. And I love to see it. Hope you're going well. Hope your coding adventures are good. Thank you for sharing that image file format with me recently. I'm keen to have a look at maybe using that for the PlayStation 2. Oh dear. I haven't made any progress on this. I haven't touched it. This is exactly where I left it last stream. How's your QOI is the image format, right? How's your parser going? We're gonna jump in and just double check what we were up to, right? Because when we're loading a level, we have a struct that holds the level, we have a struct that holds the current game context. This is kind of like a child of that, but we can have multiple level buffers, and the idea is that we can load several levels at once, we can stream levels into memory while, other stuff is happening. So we can, in theory, have an infinite scrolling world. That's one of the goals of this 2D game, testing out this idea of reloading assets and smooth scrolling, and then when we move into 3D, a lot of this machinery should hopefully be able to carry over. Cool. Every level has an allocator. So the idea is that when we unload a level, we don't even do anything, right? We just forget what we were up to in that allocator, and we start allocating from it again like it was empty. Arena-based buffer allocation. I can never remember the exact word for it. Getting glitch looking output. Something broke in your GUI library. Win32 backend, it stopped rendering correctly. That sounds like the Win32 backend experience. I'm sorry to hear that. Have you tried installing Linux? That's how I fixed my Windows UI issues with code I was writing. It sounds like a joke, but it's actually a true story. That's the best kind of joke. Okay, so we parse a level header. A level header tells us how much stuff is in the level, how many tilemap definitions, how many asset definitions, how many entity definitions. This always has to be 0 for now. It also tells us where to place these tiles in the world, and we have names. Names are good. Names are good for debugging. Cool, excellent. We probably should timeout definition. So after we've read this header, we probably should use this short name in our error logging. But anyway, that's another day's problem. So one thing we should do, right, because this function is north of 100 lines with no end in sight, we should really start to break some of this up into smaller chunks. I think that would be a good idea. I think that would be a really good idea, especially this stuff about, well, it's kind of hard. So asset definitions alloc from, textures alloc from, tilemap def count. Do I initialize? No. So this is where I need to start splitting this into parts, right? So we read the header, we get read file part. Yep, we read tilemap definitions into definition count times this. Tilemap def. Hold on, something weird happened here. Read file part header, read into header, size of a level header. We probably don't want to put this into our level header. This isn't a level header, this is our tilemap data, and we can read that. Tilemap defs. So this should go into tilemap defs. This pointer, this is where we want this to go. Good. If we haven't allocated it, something went wrong. So this is okay. This is where we read it. We move the read head up. Asset def, same problem here. It was getting quite late. Asset def. It was getting quite late when I worked on this code. So A couple of silly errors I'm not surprised to see. So here we've loaded a header and we've loaded the things that the header tells us exist, right? We know there are tile maps, we can load the tile maps. We know there are assets, we can load the assets. And they're very, very simple types. Very, very simple types. The tile map's kind of a funny one, right? Because it's a X by a Y, like we've got, actual tiles that'll be drawn to the screen. We don't know how big this is when we read them like this, so the actual map data is just somewhere in the file. We point to it later. And that's good. That makes us happy. Infinite Coder, welcome. Switching to SDL and OpenGL, it renders whatever you do. The image data does not appear to make it into a texture. Render shows it's getting drawn. The texture is whatever the standard background color is. That's really annoying. That sounds like a buffer issue, right? Well, SDL though. SDL should handle all of that for you. Yeah. That's really rough. I'm sorry. Could you try building your D code as a library and then calling it from C and having like a C OpenGL program and just make sure it isn't a problem with the D bindings, right? Just build an SDL program and literally just copy, like don't even think about OpenGL, right? Just copy maybe do that in D first. Set up a software rendered SDL window and just write to the window buffer directly, copy the pixels. You might have to do some swizzling. Even if you get the swizzling wrong, you'll get some output, right? That might be a good place to start. It's inefficient, but that might be a good place to start. You've typed my username into the URL bar first try. Congratulations. None of them are complicated words, but when you put them together, it's kind of like correct horse battery staple. They're greater than the sum of their parts. That's the goal. Okay. But congratulations, Infinite Coder. That is wonderful to hear. You haven't stopped by for a while. You should check out my new emotes. They're good. I think you'll like them. Cool. So at this point, we've loaded everything. Let's put a mark here, MA. Now, do we have to read anything else? No. So here we go. So this should be asset def count. Loaded textures allocator. Yes, we put these here. Excellent. So we probably want to iterate. We probably want to do some kind of iteration here. What's the actual def A asset defs? I look from. So we reference the asset defs list, but not necessarily the actual loaded asset. And I guess that's okay. Tile map. What is the tile map actually? The loaded level. The loaded level has an actual tile map. What is a tile map reference? Like, how do we tie these things together? Because when we draw a tile map, we need to know what texture we're drawing it with. Grab an image library that lets you draw into a PNG. That is also a good idea. Yes, screen. Excellent. Rendering broke. Closing the window no longer kills the process. Thread. Get stuck waiting for it. That sounds completely cooked. Yeah, my advice is, like, literally, I was having issues building things on Windows. It was actually this PS2 stuff. The cross-compiler toolchain was just giving me headaches. I had it rigged up. I was also doing some Haskell, and that was weird. And I just said, you know what? Forget it. Like, if you go on, I don't know if I have VODs still, but any of my streams I did in 2020, anything I did in 2020 and 2021, and then I just said, screw it. And I installed Linux, and I never looked back. Hasn't solved all my problems, but it solved a lot of them when it came to building and maintaining code. Okay, sorry, I've done a lot of milling around this code here because it's going to be ugly when I move this, but I'm going to do it. I'm going to put this in its own function, then we're going to work out what arguments it needs. Cool. So we're going to go int load level tile, load level, we'll just say load level maps. Okay, now. Cool. VOD header. Okay, so header, we need the header. We need a struct level header. And let's make it a pointer because that sounds wise. Struct. Now, what else do we need? Level loaded. We'll call it loaded. Time kind. Okay, so what else do we have? IT comes from tile map defs. We need our tile map defs. Struct tile, what is this? Level tile map def, tile map defs. Cool. Beautiful. Okay, for each of these, get a target level. We need our level as well. We'll go struct level contact level ctx level. Beautiful, beautiful. Twitch and a while. The VODs aren't the best. YouTube archive, very important. YouTube, Tom Marks Talks Code live. I've got some videos planned for Tom Marks Talks Code not live. I've had them planned for a while. One of them's about a cool wooden puzzle that I annotated with post-its, so you can stay tuned for that. I wrote code to solve this. That was a fun experience. You're doing exports to YouTube, got bored. That also, I was streaming straight to YouTube for a while, but I found the experience worse. The export isn't too bad. Making the thumbnails is the big thing that I get behind on. They are nice when they do get eventually uploaded. I'm very sorry. I am a little behind at the moment. Prop elements. Sometimes, yeah. You found me on YouTube. Windows internals. Yeah, Bobbius, you could try re-implementing in C, and then you'd know if it's your logic and you're missing something in the APIs, or if it's D. Because if it's D, that sucks, and you probably can't fix it. Cool. Anyway. Moving this into its own function is probably a really good idea. I feel good about that. So, I deleted this, right? I cut it out. Tilemap defs, alloc from. So we'll say if return 1 on error. So if load level maps, tile map defs, and the level context. Cool. I think this probably puts fname in here. Let's get rid of this. Excellent. Someone forked D. What's in this? What's in the D fork? Open D. This isn't a normal D, is it? Is it? Governance issues with D. Damn. That's pretty normal. Normal open source drama. Have you guys been following PHP? PHP's been pretty PHP. Mind has gone blank. WordPress, that's the word I was looking for. That drama has been very spicy. Cool. So for each tile map we have defined, get a reference to the tile map, check the kind. We want to find exactly one decoration map and exactly one collision map because that's what we expect right now. We might do it differently in the future, but for now we have this restriction. We're not coding that restriction in too deep, but fairly surface level enforce this. If we haven't gotten a target from that, if we haven't picked something, we just ignore it. Okay, so does this reference an asset? If it references an asset, in other words, if it has a reference that is not invalid by pointing to the biggest unsigned 16-bit number, then we make sure it's in bounds. We get the asset definition. So this means we need the asset definition as well. And then we load a TGA. Yeah, that makes sense. We load the TGA into our level buffer. Now, this is interesting, right? The thing that I find particularly interesting about this is that when I was first writing this code, I thought it was best to load the TGA when I determine that it's been referenced by something. And that's pretty good. What if I flip this around and instead of doing all this here, like this isn't actually part of loading the tile map, right? This is loading an asset that the tile map references, but I've got a list of assets and I've got a list of tile maps. Why don't I do this for all of the assets first? Because otherwise, right, What if two tile maps reference the same assets? Then they're going to double up, so we're going to load them twice, and that sucks. So what we're going to do is this. We're going to make sure it's loaded, and that's good. Wire things up. We're going to have a function as well that says, we have level load. We're going to have a function that says int load asset, load assets. And this is also going to have various arguments. We're going to do the same kind of loop. We're going to say for int I equals 0, I less than header, and this is going to be our header. See, this used to not be a pointer, but now it is, because I moved where it lived. Okay, asset def count I plus plus. This is a lot of code to write in one go with no testing. Very, very nervous, cool, so get a pointer to the thing in the array, allocate room for the name. This goes in our level map. I don't know if we actually need to copy this. I guess we do. We need to read it out of the file to somewhere, so it does need to go here. We could walk the allocator back after we do this, after we load the TGA. I guess it goes into this allocator. That's actually tricky. It's actually kind of tricky. We could also just put this, like we could alloc A and just put this on the stack. Let's allocate it into the levels allocator for now. If this is the thing that's filling up our level allocator, we've probably done something wrong anyway. Read file part, read this into name. We've done that copy paste again, which is very funny. And then we put a 0 at the end. Has to be null terminated. Let's put that there, that's okay. And then we load a target from there, loaded textures. And we load that into this textures array, which is good. And that's just a dumb array. In the future, this is going to be harder because we're going to not every asset is necessarily just going to be a TGA. We might want other stuff. But for now, we can live with everything being a TGA. That's not the end of the world. So, this logic is going to have to be more clever at some point, but not right now. Not right now. That's okay. Okay, load assets. We need struct level header. We need struct asset def. I think it's just called struct asset def. Asset defs. We need there was something else in here. Asset defs. We need the level. There's something else that I saw. Fname. We need the file name. We need this here too. Bugger. That's annoying. That's more annoying than I thought it would be. I thought that was going to be nicer. This is too many arguments, really. And like at some point you should just put them all on their own line, and that looks cleaner. I don't know exactly when that point is. Let's try this. Let's try doing it this way. I also don't think C will let me put a trailing comma here. I suspect I can't do it. Cool. Let's put everything on new lines. This is a lot of args. But this is an internal API, so it's okay. Like this is very private to how this code works. So if you're gonna have this kind of argument soup, make it very internal. Don't let this leak out into your public APIs. That's my advice. That's my completely unsolicited advice. Okay, so let's put the file name back in. Awesome. The other thing is, yeah, like where does this actually go once we've loaded it? It goes into target. Okay, no, it goes into the level. That's okay. That is okay. That's workable. The assets, this goes into loaded textures, and that's also good. Name length 0. Is this everything I need from an asset? File offset, nameline. Yeah, okay, that's good. That's good. So, what does our tile map struct have in it? Excellent. What I might need... How do we know what to reference? Hold on. How do we draw anything ever? Draw Levels draw. Oh, each level is responsible for its own drawing. Okay, that's better. That's better. So, okay. What we need to do is have another struct. There aren't enough structs here. We need an extra one. Let's say struct level tiles. Right? This is a struct tile map. And it's also going to be an int asset ref. Right? This is the asset that it references that it needs to be in memory when it gets drawn. This is the tile set it gets drawn against. Let's actually just call it texture ref, maybe. Maybe that's a better name. So now instead of just being struct tile map, it's going to be struct level tiles maps, which is now bigger. Okay, maps, load level maps. So in our loaded level, we probably want to allocate this. And even though we're doing it like this, we probably want to do this as well. So tile map defs, this goes up. Let's do it in here. Let's do it in here. Level maps. So let's say loaded maps equals alloc from alloc from allocator. We need the size, which is going to be size of struct level map times header header tile map def count. We need this many of these things. What? How did that happen? Hold on. I ended up on the wrong line. My mistake. Size of struct level map times. Let's put this on a new line because it's too long. Header tile map def count. And if it's 0, we're just going to return 1. Alloc loaded level maps. Never put failed at the start of an error message that's going to be annotated with error. If you're going to pivot languages, it won't be C. No, what I mean is just write your SDL code in C and you like call into D as a wrapper. The only reason I say that is SDL is written in C, so you'll know that the problem is the APIs you're using rather than the wrapper, right? It would just give you a more pure way to do the windowing stuff, but try blitting the texture data you get from a D library or something, right? That would give you some indication of where the things are going wrong. I can't unit render, decode is working correctly, non-GUI unit test because the output you decoded the PNG version. That is very good. That sounds very promising. The more tests you have like that, the more confident you're going to be. Cool. All right, so decoration, def count, this is feeling better. The only thing we need to do now, this is here. Okay, actually, instead of having this target, let's say this target is loaded maps I. And then we'll do this the opposite way around. We'll say level collision equals target equals. This isn't a pointer though. Oh, it's not a pointer. We have to do it backwards, right? That's hard. That's really hard. Like, there's a memory location here and a memory location here that I want to write all this to. Now, I could write them separately, but that's bad because that would probably get out of sync. Oh, that's really disgusting. That's really disgusting. Okay, you know what? Actually, instead of doing this, I've got a better idea. I've got a stupider idea. Because we actually only have one tile map for now, let's do a stupider thing. And let's say int deco map text ref. Let's do the stupid thing, right? Which is that we just store, there's only one map that can draw a texture right now. Let's just store a reference to it. Let's just store a reference to this one thing, because we're only drawing one map. The level draw, like the level has a draw function, so this is contained within the level, and this thing is kind of like the driver of all of the drawing. Let's self-contain it for now. This makes our life a little bit easier. Loading assets is still done properly. We could have lots of assets, but we can only reference one of them right now. Until we add entities that could reference different stuff as well, this is all we're doing right now. Okay, so alloc from. This is good. Wrong way. So, if it has an asset ref, we just say if not if. Now screw it. If we find an asset reference, we're just gonna say that in the loaded level, this is the deco map text ref equals t asset ref. We store this. Now when we draw, we just make sure this texture, the thing referenced by this handle, is in VRAM before we draw the tile set. That's all we need to do. Cool. Then we init it wherever this thing points to. That's good. Okay, I think that's good. I think that's actually really good. That's easier than I thought it would be. Now let's come down, loaded textures. Let's say if load assets, fname. Oh yeah, this needs the file name again. Header asset defs level. Get rid of the word fail. The word fail is redundant. Load level assets. A little bit of a redundant error message, and then we can just return 0. Everything is loaded. Except, no, that's perfect. It's in the level context. Now when this level runs, how do we actually get the level context? Because, so every level, every context, every level has a level data struct. So what we need is to make sure the level data struct for the level points to this, and that will give us everything we need. That'll give us everything that we need. We also probably want to make sure that we have a texture count so that we don't overrun either of our buffers. That's a good idea. So let's say loaded texture count equals header asset def count, and we also want tile map count. This is a tile def count. Let's also say loaded short name mem copy source destination n. I can never remember. I have to look this up every single time. If you're going to drop the GUI library and just use STL manually, you could do it in D. Yeah, okay. That would be a better in-between step. Or like I said, drop the OpenGL part and just get a window that's software rendered and write pixels to it directly. That'll at least tell you what layer your problem is. But again, feel free to ignore. Destination, source, n. Destination, header.short. Short name, I don't need that. What is going on there? Name, I don't need that. That's already a pointer. Header, short name, and n is namelen. Sweet. I love that. What else do we have? Deco map ref. So everything should be initialized after this, except for. Oh no, this is. So let's move this up when we do the other one as well. Wait, we already do that. Maps is allocated. Is it? No, it's not allocated. Okay, let's do that here. Loaded maps alloc from def this is tile map def count and size of tile map. Okay, now I think we're ready to build. Insane, but I think we're ready to build. Some of this needs to go in a header, I guess, maybe. Level load. This puts it all in. Oh yeah, hold on, that's the other thing. So level, where does loaded come from? Loaded, it's allocated to the levels allocated beautifully. And this should be the first thing in the allocator, but I'm not totally sure. So we're not gonna rely on that. Level data equals loaded. Cool. So we're saying when we do stuff with this level, just look at this level data. Now there's one other thing we have to do, which is to initialize this to actually have functions, right? It needs an update function, needs a cleanup function, needs a draw function. And we can do that as well. So we'll say level update equals 0, cleanup equals 0, but draw needs to do something. And we're gonna call it loaded draw. Has our context and our level context. And the first thing we do is to get a struct level loaded. Loaded. This needs the level loaded as well. Level loaded. Very important. Header short name. Maps I look from. Where did my call to this go? Load level maps. Did I? Oh yeah, it was here. Hold on. Load level maps. File name header loaded. Header asset defs loaded. I think I put it there. Arguments in different order between these two functions. It's actually kind of hard to see which function this is because of the if, but that's okay. We'll survive. Then we have to do all our struct setup. So draw. Draw is going to be loaded draw. Right? Use this function. And this is going to be a struct level loaded level data, right? So, you know, we don't know what kind, this is a void pointer, we don't know what it's pointing to, so we're telling it. It's pointing to this. It's pointing to this because I said so, because I did that just here. I know exactly what type of thing that I'm pointing this at. If it's something else, then we've got a problem. Then we've got a big problem. If not loaded, right? If this is a null pointer, oh boy, that's a big problem. That is a log error. That's a log error where we go level data null. And that's all we need to say about this matter, really. It's just about all we need to say. Now loaded. Yeah, loaded has a short name. Excellent. So we can't print out the name of what we think the level is because that's a badge, right? It's null. We can't get it from this thing because it's null. It's possible that this is pointing to something that isn't level loaded data. It's not impossible, but it's pretty unlikely. If I've written my code right, it's pretty unlikely. Okay, so we've got this loaded level. How do we draw it? We just say loaded. Well, actually, we probably just want to say, and let's look at our existing levels first. Let's look at test entry, draw. All it does is upload a texture to the emotion engine, bind that texture, and then draw a tile map. That is all we're going to do as well. 100% of what we're going to do. So the texture we're going to upload, instead of this, it's going to be loaded textures, and then we're going to reference this. It still needs to be a pointer. We're going to reference this with loaded. No, I didn't put a mark down. Bugger, I can't jump back. Deco map text ref. Deco map text ref. Beautiful. Now we're going to bind that texture. Maybe I should put this in a pointer. Store this in a variable, I should say. Put this in a pointer. Not absolute nonsense phrase. So upload it, bind it, and then draw it. Except draw it with this texture reference and the camera from the context. That's good. That's good. And then we're going to return 0 because we're happy. Sometimes returning 0 means we're sad, but in this case it means we're happy. Because consistency is hard. sticking to your APIs, it's pretty tricky, and it can be pretty lame. So sometimes you just have to wing it, and sometimes life's better when you just make it up as you go along. We could have sat here and like planned this out really nicely, and still have a big waterfall diagram for how it was all going to come together. Just vibes. Just vibes, nothing but. Okay, so we've got all this data. This should all be pretty internal, I think. Let's see if we can just expose. Let's go source levels fmt.h. Source levels fmth. Get level load. And this is good because all of this is actually internal here. Now, it actually probably shouldn't be. I actually want to expose some of this stuff, like this much of this stuff, right? Because if I want tools that work with this, it actually has to do this too. Make an enum for return values and use it consistently. I've done that before. Yeah, I've done that before. I should do it again. The older my code is, the more I kind of do stuff like that. The older I get, the lazier I get. Because I don't like boilerplate. Once you've written boilerplate 10 or 11 times, you're just kind of done with boilerplate. You're like, I never want to see this boilerplate again. And that's the problem with C. You get lazy, right? Everyone is a great programmer until they get lazy. In lots of programming languages, when you get lazy, the compiler tells you did something wrong. The interpreter does some weird type stuff. Maybe it's okay, maybe it isn't. In C, when you're lazy, you accidentally ignore all SSL errors and create a huge vulnerability in your BitTorrent client. That was C++. The consequences are dire, right? You forget to do your due diligence, and then suddenly NVIDIA GPU drivers have a massive RCE vulnerability. Do I know renderware system for build games? They were able to port it to consoles as well. I know a little bit about renderware. There's a lot of leaks around renderware, a lot of source out there, which I've not looked at, and I try to avoid it because I want to do this as cleanly as possible. But I know about renderware. I've played renderware games. Some of them look quite nice. Some of them look very generic. But yeah, no, they ported to a lot of consoles. It's kind of wizardry that they got it running on so many consoles. I'm really interested in what their data structures are, but because the full source code of the engine is leaked, I'm just kind of scared to touch it. In JavaScript, when you're lazy, something far away from where the problem is does something insane. Yeah, you're like, why is this nan here? Why is this a nan? What did I do? How far through the call stack has this nan persisted? I don't like that. I don't like it when that happens. Okay, so level loaded. Level loaded is the important internal detail that we never want to expose to anything. This stuff actually should be out here too. And in theory, at some point in the future, we'll actually check the version and the ID, but not today. It's not so important today. You didn't hear about the leak? I mean, there are a couple of different versions. As far as I know, I'm not super across it. Like I said, I try to avoid it. But there are versions of renderware out there. Let me just Google it, right? If I Google GitHub renderware PS2 source reimplementation, GTA 3, no. Open source. Open renderware Studio 2.01 and graphics SDK 3.7. I think this is a leak of the whole SDK. So yeah, it's out there. Yeah, exactly. I think that's the one I just found by Googling. We struggle with 3D source in this engine. Behender and progs. Yeah, no, definitely. Like, formats are weird. The PlayStation 2 formats are weird. I don't condone clicking on this and looking at it. I officially do not condone this, right? But it's out there, and it's really hilariously easy to find. It's hard. I think I said the other day, right? I had this, not argument, but I raised this point in a PlayStation 2 reverse engineering Discord because I found, hold on, I think I showed this the other day, right? I won't show it again, but basically there's a Kingdom Hearts reverse engineering project, and they just have, and this is common apparently to PlayStation 2 reverse engineering projects, they have Sony copyright headers in GitHub, and it's just like, it's a bit unnecessary, right? I get why they do it, but it means that if Sony ever want to shut it down, that and all derivative projects are all in danger. Anyone who's looked at it, right? And I've just said that I've looked at it, I've seen Sony code. I didn't keep reading it once I saw it was copyrighted, I promise. Sony lawyers, I swear I didn't read your code. But I did look enough to notice that it was copyright. Cool, so this looks good. This looks reasonable. This looks reasonable. The only other thing I want to check, when I load these levels, do I do the offset correctly? Yes, I do. I do. This is good. This feels good. Can I just throw this in here? So what if now level load? So, okay. Fname. Where do I read file part? Fname. Yeah, okay, this looks great. This looks really, really good. Read file part, defs. This looks good. Let's try it. Let's try it. So let's go into source levels, test load. Let's go into test load.c and let's nuke it. I don't want to do this anymore. I don't like any of this code anymore. Let's import a couple of headers here as well. I think that's probably a good idea. First off, let's include, when I say import, I mean that really lightly. fmt.h, just from right here. Let's import some other things. TGA, yes. Tiles, yes. Levels, yes. Draw, yes. Context, yes. Beautiful. You only found a few videos about using it in 240p. It's very old, right? It's very old stuff. You know, renderware, right? From like 2000, from the early to mid 2000s. That's ancient. 240p was high definition back then. That was all the pixels we had in the year 2003. Those were all the pixels on the internet. Right there in one video. Cool, test load. Okay, so here's what we do in test load. Here's what we do in test load. Test load init. Test load init. Okay, so we need this function still. We need this function still. I was a bit overzealous, right? This is our entry point. When we want to load the level, this is what gets called. And all this is going to do is call, in our format file, it's going to call this level load function. It's going to call level load. I'm going to say if level load, that means something bad happened. So we pass in a file name that's fixed. We pass in a file name that's fixed. And this file name is going to be... What are we going to call it? Let's call it level. Let's call it load.ps2 level. That's what my file extension is going to be. I just made it up then. We pass in our context and we pass in a level context. Beautiful. That simple. It's that simple. One guy is doing an engine implementation, things by reading assembly himself. Those people are wizards. That's correct. He chose C#. You want to learn Rust. I've been doing some Rust streams as well. Rust is very good. You want to install Windows to be able to use Discord in your country. You have problems with KDE. Man, that sounds like there's a lot of stuff going on. Rust is cool. Highly recommend learning Rust. Highly, highly recommend it. Okay, so if level load, if this returns non-zero, then we need to say log error load fail. And we're going to return 1. Otherwise, we're happy. That's it. That's all we have to do. This is now our entire load code. So let's try compiling and running this and see what happens. Let's try. The other thing we need here is fmt.h, because that's where this comes from. What happens if I make? What if I make C source? Cool. Okay, let's go through our quick fix list. Return 0. We're happy campers. Unknown type, that's because we didn't include stdint.h. There's actually other types here that are going to give us problems. No, there aren't. They're all just numbers. And this is the point of the file format, right? There's no weird dependencies. Like, these headers, that's it. And we do need headers for game context, and so we do need this header, but only for that function. The actual types, they're fine. They're very simple. C# not a bad language. KDE is awesome. KDE is pretty awesome. I have no hate for KDE. I use a weirdo tiling window manager, but I respect KDE. Various widgets broken, no new versions. Ah, interesting. What version did they upgrade to? You've only heard hate about Rust. You haven't been listening carefully enough. Embrace the crab. Rust is good. Rust is really good. It's hard, right? Don't confuse people saying that it's hard for people hating it. Too few arguments to alloc from. What's my alloc APA? Num size. Okay, so I just want to allocate one of these, and I think I made that error throughout the entire file. Oh wait, hold on, no. This is good. Why have I written this stupidly down here? Why have I done this multiplication? I just need a comma. Just need a comma. Replace multiplication with a comma. Let the multiplication happen internally. That's good. Alloc from invalid initializer. I'm implicit declaration of that. That's because we need io.h. Well, people don't understand the trade-offs. Yes. KD is a corporation. Plasma has polonium. Interesting. Yeah. No, I just like to use as few resources as possible on my system. That's my goal, really. Power consumption. New one only works with Intel. Oh dear. Manual memory management. Rust handles it for me. Well, Rust manages some of it for you, but it makes you think about the layout. So you know, a bit. I would say that's a little bit of a misnomer in a sense, misnaming, I'm struggling for the right word, but I know what you're trying to say, and I partly agree. I partly agree, despite being contentious, unnecessarily contentious. Invalid initializer, level loaded. What does this mean? Invalid initializer? Huh? Level loaded. Level loaded. Level loaded. This is a alloc from. That's the problem. That is the problem. It's of course, you can't initialize a struct type from a void. But yeah, no, highly recommend giving the world of tiling window managers a try. It's hard, right? It's really like it's a big paradigm to get used to, but that's what I'm using here, right? This looks like a fake window because I'm really clever like that, but it's actually my entire window manager just inside a fake UI. My mouse doesn't go any higher than this, right? This is my whole screen right here. Yeah. Cool. Rust doesn't allow certain common patterns. That's a good way of putting it. Ever tried writing a linked list in Rust? You might have a hard time if you're used to C, because it's like, whoa, I can't keep track of this because these things could reference themselves. Right? I don't know what the hell's going on. Rust like kind of gives up the goat. Okay, where are we? Too few arguments to IO read file part. Uh-oh. Header. What am I missing? IO.h. What am I missing? Read file part. Target buffer size. Yes, target buffer size is the thing. So size of struct level header. Cool. It's not make B anymore, it's this. Logger, I have not included my error logging. Include p2g log.h. Okay, now we're gonna have to fix this a couple of times because I'm really silly. So now we need this size. Oh, for fuck's sake. I think I just had a little bug on my leg. You don't write a linked list in Rust, you use an existing one? True. This is true. Rust is bad for reverse engineering. This is... try writing a doubly linked intrusive list. You learn what RC and weak are for. Yeah, you had some stuff to say about weak when I was struggling with this. And I learned a little bit about weak. And it wasn't the problem that I thought I was having, but it was interesting to learn about. I need to do more. RC is a really cool type. I love the idea of RC. RC does not fit in here. Why doesn't RC fit in? If you're talking about linked lists, isn't RC kind of what you want? I'll bite. I'll bite here. Doubly linked list, maybe not. Singly linked list, I thought RC was okay. Doubly it should be okay as well, right? Isn't that kind of like you just need a box? Reference counted RC, yeah, exactly. It just counts. Doubly linked list RC fits. Why not for singly? And like it works. I don't know if it's a good solution, but it does work. For single list you just need a box. Yeah, but why not make it an RC, right? like just is not enough for me here. I have used RC for this because I think it makes more sense, especially if you're like building a Lisp. You don't need to share ownership. What if you do, right? What if you do something that, like, what if you could have, say you have consoles, right? You could have two consoles that both have the same tail, hence RC. You might want to clone. Okay, anyway, sorry, read file part. I'm getting distracted again. Read file part. I've just realized something silly, right? Which is that tilemap defs, we want, so read, this is where we start, this is where we stop. And we really just want to like duplicate this. This is our buffer size. We need to be, actually it isn't. Alloc from, alloc, yeah, no, this is our buffer size. Okay, so I've basically just forgotten to give it a buffer size every single time. RC is a reference counted. Weak is a weak reference which doesn't contribute to a ref count and breaks the circular reference issue. Interesting. Yeah, okay. So that's where you kind of just say like, trust me, bro, I got this. And you tell Rust that you're gonna keep track of this stuff and clean up after yourself, right? Okay, so what's next? Load asset. Implicit declaration. That's because I defined it after the thing. So loaded draw. This has to go up here. We need to just forward declare. What else have we got? Load assets has to get forward declared. Load TGA. This also has to get forward declared. Forward declare all the things. Let's do normal P. Except this has a really long function signature. That I need to copy in full. Cool, and now I just need load tile, load level maps. We need this one as well. Okay, now we should be better. Now we should be in a better place. And of course, there's still a bunch of rows, but that's okay. That's okay. Can you learn about it in a book? Rust books are tricky. There's a good Rust book by a guy called Tim McNamara, and I'm not only recommending that because I met Tim, but it's a good book. I think it's Rust in Action. Advanced concept makes you memory like box leak. Yeah, exactly. 99.999% of Rust code should never think about leak. Like it should be somewhere in your core library somewhere, and then you build an abstraction over the top that makes it better. Weak pointer. Yeah, it's like the weak pointer smart pointer in C++. True, very true. All right, level loaded, declared inside parameter list. Oh yeah, that's a good point. I need to declare this first. Now, because it's a pointer, I think I could actually just forward declare it and not care about the size because I never pass it by value anywhere. So like these functions, they don't need to know how much to actually pass. They just need to know that it exists, but that's okay. Load asset. Yes, I meant load assets. What else do we have? Header. This needs to be a pointer. Memcopy. Unincluded. This comes from string.h. Weirdly reliant on string.h for memcopy. Alright, we've got a meaty comment that I'm gonna have to dig into in a second here. T asset ref. Hold on, that's not what I want. I want I. Give me I instead. T asset ref. No, give me I. Everywhere we see a T asset ref, this should be I. Good. Alloc from, too few arguments. That is correct, because we want one of these of size that. Now, we want a name len. This is the size of our buffer. Good. RC undeclared. Should be an int. Okay, now we're getting somewhere. DXX type int has type uint32t. So everywhere we log a uint32t, it should be an LD instead. Symbol box, symbol ref. Symbol box is a smart pointer you can create from the inner value. Symbol ref is something you create using symbol box create ref. Access the inner value unless it was destroyed. It sounds like RC and weak. Yeah, that sounds a lot like RC. Being destroyed, but without the destruction check. Okay, interesting. Yeah, but that does sound very RC-y. I guess the hard thing is, right, it's the reference back to the parent that is tricky. And that's because to know if it's been destroyed, you need a reference back to the parent. But I don't know how well that works. A list of references. Yeah, like, I think the thing that Rust doesn't like is that bidirectional reference. You could do it with unsafe. You could probably do that with unsafe, but you just can't do it without unsafe. Yeah. You can. Yeah, but there's some soup of types that I'm not familiar with. You would need to do that. But the bidirectional nature of it makes it more tricky, right? Okay, so log, let's find where these things are. Load level S, I, so where this is, we'll say LD instead. Log air, load level S. That's fine. Header asset def count. Now this should be a pointer, and this should be a pointer. We'll make this an LD. Cool. What's its problem with this line? It wants this to be an LD as well. Return, what do we return here? We return 0. We return 1, and then we return 0. Okay, we're getting to the last few errors now, and that's good. We're building. Okay, let's make run. Let's do it. I've got my controller that should be plugged in, and here we are running in a real PlayStation 2 emulator. We'll hardware test it in a sec. Once we hit this point, we expect it to basically crash, because it won't be able to load. Okay, well that's cool. It errors, and it knows that it failed to load something, but it doesn't actually kill the game. So that's kind of nice in a way. Cool. And all it says is, yeah, we can't find the file that we're looking for. That's cool. So we tash the thing. Excellent. So now we just need to write a file with the correct format. Oh, actually, no. Wait, did we remember to load the actual tilemap data? We didn't. So then we forgot something very important, which is to get the actual tilemap itself. Now, after we've called tilemap init, if we look at tiles.c, tilemap init allocates the actual tiles array. So we should be able to say io read file part. Now this is a bit dicey. This is feeling a bit more loose than previously. So the name of the file, the buffer we're writing to, the length, the start and the end. Okay, this is good. So the name of the file, the buffer we're reading to, which is target tiles, which is a pointer because it gets allocated. The tiles, and it gets allocated into our level allocator, so this is good. So it all gets cleaned up. We love this. We're very happy with this. The size of this thing is going to be t size 0 times t size 1, right? The dimensions of the tile map, because each tile is 1 byte. That's our restriction. We start at, now this is the other tricky one. Yes, okay, no, that's fine. This is the other tricky one. So the start is, hold on, and we actually have this in a different file now. Tilemap def, map file offset, and we read until t map file offset plus t. Let's put this in a variable. Let's go uint 32t map size equals this. plus map size. Read that many bytes. Okay, good. And now we've just copied the tiles into the array. Cool. So we should be able to write a very, very simple level file that respects this, I think. And this one, I can't tell if this is going to be easier in C. This one actually might be a lot easier in Python. Okay, so let's do it. Let's say let's level test.txt. So what's this going to be? Let's maybe say, what's this format going to be like? How are we even going to do this? How are we even going to represent all that data? So format.c. What is the header? Format.h. Hold on, I've got too many things open. So, you know, we've got th header. So we have a name. And this has to be less than 24 characters. So let's call it this. So the first line is going to be this name. The next line is going to be a world offset, which is going to be at. Now, I should have kept my old file. I should have kept my old file. So let's git diff source levels test load.c. Where did this tile map go? It went at 130 times 16 negative 16. Okay, that we can do that. So negative 16y and 130 2080. Oops, 2080. Not that other number. That was too many numbers. Things you go, yeah. Why do programmers write something equals source plus size instead of making a function for it? What would the function do? A function to add two numbers is a little bit too simple. And, you know, if we had some abstraction for a list that had the size included, then a function would make more sense. But because we have to manually keep track of how long the list is, how long our arrays are, and those variables live at the same I guess, level of the same stack, the same context, the same like place. Like they live next to the actual initialization of the data, the allocation of the data often. So we just juggle them ourselves. It basically, you know, I just take that all on my shoulders and I deal with it. No, it's all good. I'm happy for you to ask questions. Anyone is welcome to come in and ask questions here. Don't feel like you're being annoying. I may not answer all your questions. Some of them may be too nebulous for me to get into. I have a lot of thoughts and opinions about programming, but seriously, you are welcome. You are welcome to question things that I do and to you know, suss out what's going on. Do I want my own file format here, or do I just do it in like JSON? Is that going to be better? I have no love of JSON, but that honestly might be better. Version we don't care about, so let's say maps. Let's go assets, and this for now is just going to be a dumb list. Let's say the asset is going to be assets tiles test1.tga tiles test1.tga. This is the file we're going to load, and I guess we can't have a trailing comma. Do I have a rant about is odd and is even as dependencies? Yeah, I've given that rant before, I think. Left pad and whatnot. Is odd and is even are probably more egregious because the modular operator exists. But yeah, like, you know, small dependencies are bad. This is a lukewarm take. This is an ice cold take. It's been said many times. Cool. So I think this is going to be sufficient for now. Oh no, we did an offset as well. let's say offset X, what did I say, 2080, and offset Y was -16. Beautiful. So we have our assets, and then each map is an object, and that object is gonna have offset X, which is gonna be 0, offset Y, which is gonna be 0. We're not offsetting this tile map from the overall levels global position. Size of the tile map. Well, we don't need to calculate that explicitly. Kind, we'll say kind. Deco, we'll say texture 0, like it references this thing here. And the rest of this is going to be automatically calculated because we'll say tiles equals yeah, let's do it this way. So we'll go 0, 0. We'll do a list of lists. List of lists kind of sucks, but or do I put it all in a string? That's the other thing. Nah, look, let's do list of lists. I think list of lists has the most merit here. Let's go let's go 20. I love Vim. I love Vim so much. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, maybe. Let's do that. And then we need to do the same thing for a collision map. So it's annoying having to do this thing twice, but that's the price we pay. Yeah, don't implement small things. When you're learning, it's best to use libraries, write everything yourself. This is my approach. When I learnt Rust, I wrote a virtual machine programming language compiler, knew nothing about the language, did a lot of things the wrong way, but man, I learnt quick. You can't learn how to create a window, no good materials still. Get something done, libraries are useful. Yeah, look, honestly, like, creating a window is weirdly complicated. You would think it wouldn't be, but in today's programming environment, doesn't matter if you're on Windows or Linux or Mac, it's one of the most complicated things you can do. It's boilerplate, so it's something you do once, and then you don't really have to do it again in your program, but it's something that I have to look up every time, right? So some of these things, and it's hard because you don't know what is gonna be hard. Like, someone just starting is like, I'll just make a window. And an experienced programmer's like, well, you're gonna find that challenging for these reasons. Okay, so, but start with like command line applications. I think that's honestly the best thing you can do, because printing text and reading text on the command line is well understood. That's a great place to start. My first projects were little console-based games, and they were awful, to be honest, but I learned a lot doing them. Okay, so let's just put some random tiles in here. Let's go 2, let's go 3. Let's maybe change these. No, I can't just do that easy. TUI is fun. TUI is really fun. In Rust, there's a library called Ratatouille that I was looking at the other day because I was thinking about a TUI debugger for my virtual machine. But it looks like a little bit too much work. I'll do a stream of it one day, but not today and not tomorrow. Okay, so let's see if we can quickly hack something together that's going to turn this into a file. Actually, I might have to go. I might have to like leave this with a teaser and promise to do this off camera. This is a bit of a weird stream. Again, this is more of a podcasty stream. And actually, that reminds me, I meant to send... I might be doing a little session with another PS2 coder. But we're making progress on this, right? We're getting really close. Off camera. I'll do this off camera. I'll do this off camera. And then we won't do the tedious Python file IO stuff. It's not that interesting. But once I come back, I'll hopefully have a file that I can load into a level. Then we can start doing more interesting stuff. And hopefully... like, this will be a little placeholder, it'll be useful for testing, but the main goal is to do levels in tiled and bring those into the PlayStation 2 directly. And maybe have hot reloading. That would be a fun thing to try and do. That should be really, really easy to support with how I built everything, so that would be fun. But for now, I think I'm going to head down to the pub and maybe play some Irish music if they're doing it. It's a public holiday today, so I don't know what's going to happen. So, let's find someone fun to raid, let's throw some of our viewers on, let's throw the love over to another amazing streamer. Yeah, TUI programming is really, really fun. You can do all kinds of really cool things that you may not expect. Aston Chan. Are they live? Game Boy Assembly. Oh yeah. I've rated them before. You don't know how basic IO implemented in system? You'll learn. You'll learn by doing. And that sounds like a shit thing to say, and it's hard, but like you just got to give it a try. And when it goes wrong, ask some people for help, and keep learning. There's no easy process, right? It just takes a lot of time. When I started, I also, Bobbius, I don't think they're online anymore. They were online before. I saw them online before, but I can't see them. I don't think they're online. Category software and game dev. But yeah, no, you learn stuff by doing. That's all I can say. When I started learning to code, I bounced off of it really, really hard. Like I tried and I was like, this is too hard. I can't do it. And I gave up. And then I came back like a year or two later and I learned a bit more. And I was like, this is too hard, and I gave up. And then I came back for a little bit longer and I tried a little bit more. And then I gave up because it was too hard. And eventually, after 3 or 4 times of that, I was like, hey, I actually get it. I can write code. And then I was happy. But on the way there, I was pretty sad because I felt like I couldn't do anything. Simple geometry. Took me 2 years to get programming. Yeah, exactly. It takes a long time until you really think in code. So don't expect it to just happen overnight. Armored Core clone in Godot. Where's Cricket? Is Cricket here? Sounds like your kind of thing. Let's raid this. It sounds fun. Armored Core, Godot, these are 2 things I like. I've actually never played an Armored Core game, but in theory, I like it. So thank you very much, everyone who's tuning in. Thank you, everyone who's following on YouTube. I apologize specifically to Prof Elements, who is very aware that I'm behind on my YouTube VODs, but I'll get that fixed. I'll get that sorted. So Prof Elements, when you see me saying this, just like send me a message and let me know you're still following along. Love it. All right, thank you so much. Let's go on with this raid, and I'll see you next time. Bye.